All right, hello, and welcome to THR111. So today we're going to do a introduction on media design. Um, Great, so let's get started. So today we're going to talk about equipment and operation. So I'm first just going to talk about what is media design, right? So in a general sense, if you think about media in a theatrical setting, you might think of just projectors, right? Well, it can mean a lot of different things. So um, really anything in a show that involves any kind of what you would think media is would fall under media design. So computers, phones, tablet, projectors, television, LED walls, any kind of all of that falls under media design. Um, and to kind of get you a sense, so there's these two videos here. I won't play them here for the sake of time, but feel free to watch them. They're really interesting. They're kind of a great overall sense of to get what media designers in a theatrical setting do. So, when we talk about media design in a theatrical setting, we mostly refer to projection. It's kind of the most common way that we use media in a theatrical setting. So, I'll mostly be talking about projectors and projection. So, similarly to lighting, I'm going to talk about kind of the people. So, who are the people behind media design? And similar to in a lot of these areas, work the same way in the sense of who reports to who, right? So first we have our projection designer, right? Our designer that's handling all of the aesthetics of the show in terms of media. Um, excuse me. Ooh. So they're the ones that making all the big decisions, right? And underneath them is usually an assistant or two. So they assist in kind of anything that the designer would need to kind of execute this design, whether it's paperwork, hanging projectors, stuff like that. But there's usually a designer that's kind of making all the big shots. And then, of course, we have, similar to our master electrician, we have our projection engineer, is responsible for ensuring the realization of projection designers' system diagram and supervises technical aspects of projection equipment and technology for production. Right, so they're making sure that the design is being executed. Right, they're taking all the drawings, all the paperwork, and they're realizing it in the space. So you kind of heard me refer to this last time in the system diagram. So in the world of projections, we don't have light plots as more we do have a system diagram. So a system diagram illustrates the projector power, networking, cabling plan for the production. So it does the same thing in the similar sense where it's a form of communication between the designer and the engineer, right? So it's usually created by the projection designer or the assistants, right? And then it's executed by the engineer. And the great thing about system diagrams is they don't follow as stricted rules of, say, a light plot would. They can kind of be kind of any way to show your designer to your engineer how they want everything plugged in and how they want it working. So you can kind of see this example here, and I'll kind of walk through it because this is a pretty typical setup of how a system diagram would go. But really, they can be set up any way they want. So you can kind of see, so we have all of our projectors. This is a pretty big show, right? We've got what, 1, 2, 3, 4, 5, 6 projectors, right? And you can kind of see they've got their names next to them. Those are just the brand names. And then underneath that, we have how much power they need, right? So if you remember me talking about back in circuiting, talking about volts, right, and amps. So we can see that this requires 120 volts and 15 amps, right? And this requires 208 volts. And this one requires 220 volts, right? That's a lot of power. So we kind of have to make sure that we're delegating the power needs of our projectors, kind of what we need. So sometimes they might plug in a projector into 2 dimmers in order to kind of get that 220 that we need, or so forth like that. But sometimes some theaters will have 208-volt outlets available. But that's usually assigned with the projector. And then you can kind of see in this system, which I'll talk about queuing systems next class, but each projector or clump of projectors needs its own computer in order to process all of the videos or graphics that's being projected, right? So that's what these little black boxes are. Those are just little desktop computers with their IP addresses so that they can talk to one another, which are all connected into this giant hub, right? Into these hubs. So really, I won't get into the nitpicky of things, but know that this is really just to divert power and making sure that everything's talking to one another. So yeah, projector parts. So I'm going to talk about just the certain parts of projectors, how they generally work, and kind of hopefully give you a good understanding. Um, so every projector, like kind of like lighting instruments, they all have a lens. So the projector lens distance dictates how large the final projected image will be at any given distance from the projector, right? So we have to make sure that whatever image we're projecting can be thrown far enough that we need it to and at the right size and so forth. So that's what the lens takes care of. And we uh, can tell the difference between each lens by their throw ratio, right? Projector lenses are designated by the image size in relation to the distance, which is the throw ratio, the distance from the surface divided by the width of the projected image, right? So if there's a high throw ratio, numbers are long throw ranges, which means the projector will generate a small image from far away. Low throw ratio numbers are short throw lenses, which means the projector will create a large image from up close. So the best way to explain this is a high throw ratio lens will be used in, say, a theatrical setting because sometimes a projector will have to be up near where the lighting equipment is to kind of be able to hide it. So we need a high throw ratio to be able to throw an image pretty far across the stage. Where if you're projecting a low throw ratio lens will be used in a typical classroom setting, right? Because your classroom projector is usually pretty high up and then it's being just projected onto a wall that's pretty close up, but we want to be able to see everything. So hopefully that helps. And then every projector has a lens shift. So most projectors allow for a limited amount of image movement along the horizontal and vertical axis by shifting the image plane within the projector. This function allows you to move the image without having to move or angle the projector body. So if anyone's seen really bigger projectors, they're quite heavy. Even just projectors in general are pretty heavy. So we don't have the luxury of lighting instruments where we can just easily move lights and stuff like that. So in a setting like this, we have lens shift, what helps us just shift the lens easily without having to move the actual projector, which comes in handy a lot. You can kind of see this in this image below, how that works. It's just a little thing that really helps in the long run. And then lens focus, just like lighting equipment, but more specifically, projector must be checked for focus for every show, just because things get knocked around and stuff like that. And we're not just projecting light with projectors, we're projecting an image. So making sure that image is focused is really important. So that's usually checked before every show. And you can kind of see this in this image. So in a projector focus, what we do is we pretty much have someone focusing the projector and then someone standing up to whatever surface is being projected on, and they're just adjusting the focus until you can see every little square of pixel, right? And that's just how we know the image is focused. And then projector parts, so similarly to lights, projectors have lamps because we have to have some kind of light source to project our image that we want. So depending on how big or expensive your projector is, there might be multiple lamps. Now your big movie theater projectors might have up to 4 lamps or so just because they need to be able to project it that far, right? So, and these are just some kind of helpful hints to changing a lamp in and stuff like that. So, but knowing that projectors do have lamps in order to kind of have a light source to be able to project the image that we need, right? And comes with that, if you know about lights at all, because if a lamp is on for a long time, it gets really hot. So projectors have fans built into them to make sure that the projector doesn't just overheat and melt, right? So the fan is a really, really important part of a projector. So never unplug or hard switch off a projector until the fan has stopped running completely, right? You've kind of noticed this before too, if your teacher's ever turned off the projector, but it seems like it's still running, right? That's just the fan still running because even though the lamps are off, there's still heat within the projector, right? And the fan is running pretty much to cool down the projector because if you turn off a projector before the fans are off, it'll just sit in that heat and it'll melt things, and that's just not good. So the fan's a really important part of a projector. And similarly, the power, um, a lot of, and if you remember me talking about, all projectors take different types of power, and making sure that it's getting enough power is really important. If a projector is being have too much power or is underpowered, it'll cause the image to brown out. It's just sorry, that's my dog. It'll cause the image to kind of be dim, right? So making sure that it's getting a constant stream of power is really important. So if we are plugging in a projector into a lighting dimmer, we're making sure that it's not dimmable, because if we dim the power to a projector, then the image won't show up right. So we got to make sure that it's not being dimmed. Um, and next, I'm going to talk about different cables and ports that you'll see in a projector. Just kind of make sure you're getting the kind of being able to understand the difference between the two, right? So these three are probably the most common you'll see when you come across any kind of projector, right? I'm sure you've seen this in your own home before, but kind of getting an understanding of how they work, right? So this first one, which is up on the top right, this is our VGA. This is a pretty common way. You'll probably see these if it's plugged into your computer monitor. That's a pretty typical way of how it's done. Um, the only thing about VGA is it cannot carry a distance very far, and it's still an analog signal, so it's not as reliable. And then when we get down to our DVI, a DVI carries a digital signal, which can it can only carry up to an accuracy of 6 feet. So if we need more, we need to add a switcher onto it, which I'll get into in a minute, in order to add more cables onto it. So it's great for, like, say, computer monitors, but running a DVI cable, 50 feet across the length of a stage is not going to be as useful unless we have the proper power behind it. And then lastly, we have our HDMI, which I'm sure you've all heard of before. This is a pretty new one, and it can carry a digital audio and video signal, which is really useful, up to 50 feet, right? And if we go past that 50 feet, then we'll need a switcher in order to kind of add that extra power, which I'll get into. Mini display port. So this is a Mac type of signal. It carries digital, video, audio, and data, right? So it's really useful. It can't carry very far. It's usually just there to convert from analog signal to digital. We have our composite video, right? This is pretty typical. You've probably seen behind your TV. You're plugging like a DVD player in or something like that. We will use it in theater sparingly, in the sense of we might use it for monitors and stuff like that. But for projections, we don't use it as often. And then our Ethernet. So we use Ethernet a lot because it can travel a very long distance without needing any much power to kind of be behind it. It can carry video signal and other data in both directions, which is really useful. And it's something that we use to kind of communicate with everything. And then lastly, we have our BNC, or an SDI, which carries an analog signal that we use mostly for cameras, right? If we have a camera focused on a musical director that's conducting a musical, right, we'll have a video camera set up there, and we'll use that for that. So, and then remember talking about external connectors, right? So if we're going from, let's say we're going from DisplayPort to VGA, we'll need an adapter. There's a lot of examples of this, from going to VGA and DVI and stuff like that. But you'll see these pretty commonly. And then VGA to Ethernet adapters, right? Like I was saying, we use Ethernet a lot because we can send and receive messages, but we need adapters in order to transfer that signal, and those adapters need power, so we have to plug them into the wall as well. But it allows us to transfer an analog signal into an Ethernet cable, which can then run up to really as long as you need it, and then transfer it back to a VGA. So we can send and receive data really easily through these, but we do need adapters for them. And a lot of these adapters require power, some kind of power source in order to work. And then sometimes we'll use something called an external graphics card, because sometimes what we'll be doing is playing multiple videos or multiple images at once, and sometimes a projector needs a little bit of help. So we'll use an external graphics card to kind of split our signals and kind of come into one and then come out of our projector. But again, we need to plug it into a wall in order for it to kind of work. So a lot of these need power, and some of them are run by USB. which means you can just plug it right into your computer. It can run off the power in your computer. Um, and then last, we have a signal splitter, right? This is used to boost signal. So if you remember talking about a DVI can only handle up to 6 feet, well, we need a signal splitter to kind of stretch that another 6 feet, right? So that's why not DVI is it's not the best use always, but say we're running a VGA cable that needs to go 100 feet, but we can only do 50 at a time. So we'll use a signal splitter in the middle to kind of be able to boost that signal across. So yeah. And then lastly, I'm going to talk about projector terms, right? So these are terms you'll hear projector people talk about a lot, and kind of just how we kind of use projectors in the theater. So lumens, similar to lighting, lumens is the brightness of a projector, and it's usually measured in lumens, right? So this is a number. This number is only handy in comparing projectors from one to another, right? So the lumens of a classroom projector will be a lot different than the lumens of a movie theater projector, right? So it's good to kind of turn those terms. And the final perceived brightness is not only determined by the lumens, but it's also determined by a lot of other things. Again, like the lumens or the lens that it has installed, right? The distance of the projector, the gain of the projection surface, which I'll get into in a minute, and the amount of ambient light. So that just refers to how much light is in the room. Because if you're in a completely black room projecting something, it'll be a lot brighter than if you're in a room that's in the middle of the day with a bunch of windows open, right? So kind of keeping these all in terms with one another kind of helps you finalize that kind of perceived brightness of an image. So the processor also depends on how your image will look. And to kind of put this into terms, hopefully you understand, in the lighting world, think of a processor as like the difference between a halogen bulb and an LED, right? So this is the kind of the same way. So what kind of image you're getting? So a DLP is a digital light processing. LCD is a liquid crystal display, and laser are most commonly in modern projectors, right? So it's kind of really the difference between a halogen bulb and an LED, right? So being able to kind of tell the difference between those, but knowing that not only one is not always better than the other, but it really depends on what situation you're in. And then resolution. So I don't know if I've talked about this yet. So the resolution of an image is determined by the pixel density, or the size of how many pixels are in this image. Now, a pixel, which is considered a picture element, in a digital sense, pixels create up all images in like a screen or a projection surface. So the best way to describe it is the more pixels an image has, the better quality it'll be. The lower pixels it has, the less. And you can kind of see that in these two pictures of these penguins. Now, this is important to keep in mind because the bigger your projector, the more pixels that it will, pixels that it will require than a smaller projector. So, kind of keeping this in mind when you're selecting images is important. And then contrast ratio. Projectors often list the ratio of projection black to projecting full white. This ratio would be a handy number if the reports weren't so inflated. Contrast ratios tell you the luminance detail that you can play with, right? So this is a way to kind of tell the actual lumens of a certain projector, right? Something with a low contrast ratio will give you more blacks and whites, but the shift from black to white is more apparent than something with a high contrast ratio. And this is, again, this is just to compare different projectors to one another to kind of tell quality, and but not that one's always better than the other. It really depends on what situation you're in. And then lastly, I got projection surfaces, right? So rear projection is something we use in the theater a lot, and this refers to transmitting or projecting a certain image or video behind a screen, a certain rear projection screen. And this is just a way to hide projectors in order to not, so if you have a projector in the front of the house of the theater, you'll see the image projected all over the actors, and we don't always necessarily want that. So what we'll do is we'll do rear projection. And that's useful because we can project an image from the rear, and we'll be able to act on stage and not have really any of that interference from the front projection. But it does matter what kind of rear projection screen you use, because if you don't use a specified rear projection screen, you'll get what we call a bloom. And a bloom is if you ever stand in front of a projector, it's just that really bright spot of light And what a rear projection screen does is it kind of gets rid of that, so it just all looks natural. And then front projection, of course, is kind of the most typical way of using projector, where we just project the image from the front. And then viewing angle, especially viewing angle, is really important to take in consideration when projecting media, because someone's sitting from, and I'm sure you've kind of experienced this in a movie theater. You know, if you're sitting right up front, it's not really the best quality as if you were sitting kind of in that sweet spot in the middle, and that's kind of the same. So if a theater is set up kind of like a thrust style, the seating in the front will kind of look brighter than the seating from the side, right? That's just because we're viewing this angle. Um, so, and then lastly, I think I forgot to mention it, but the gain surface of your area refers to how bright or dark the surfaces you're projecting on, right? So classroom projectors are projecting on a white screen, right? That's a really high gain because it's just pure white. Now, if you're projecting it onto a black wall, that would be a really low gain. So taking consideration of where you're projecting is really important too, as far as what your image quality will be. So yeah, so that's it for this one. Stay tuned. Thank you.